Halo, Assalamualaikum dan salam sejahtera. Kali ini kita nak teruskan kuliah kita bagi tajuk Transfer Functions of a Physical System. Sebelum kita continue, elok rasanya jika saya membuat sedikit revision kerana sudah hampir 2 bulan kita tidak go through tajuk ni. Okay. So dalam tajuk transfer function, the first thing yang perlu kita faham adalah the system of the control, which is we have a input which representing of the RT, and also we have our output which representing of CT, right? And the inside of the system we call as a block diagram. So in order to find the to get the Laplace transform of the function of ft, we will get the form of the fs in terms of the Laplace transform is equal integration of the 0 to infinity ft, the functions of your system, epsilon negative st over dt. And also if you want to inverse the ft, you have your ft, you have your fs, and then you want to inverse into to get your ft, you can inverse Laplace by using the equation of 1 over 2 pi j, the integration of the sigma over j infinity or to sigma plus j infinity, the functions of the Laplace fs e st over ds, or you can get, and then you can get your ft ut, and the ut here, if your t is equal is greater than 0, your ut is equal to 1. However, if your t is less than 0, your ut is equal to 0. Okay, so that's the things that you need to remember about the transfer function. For the second one, you need to understand about the partial fraction expansion, how you want to do your partial fraction expansion. The first thing about the partial fraction expansion is in order to find your Laplace form by simplify it into a standard form. So you can use your diagram, is you still remember your table. So from that you can use your table directly by using the partial fraction expansion. You in a simple word, you just simplify your denominator in order to simplify your transfer functions, your Laplace function, and then your ns here will distributed into new parameter which is k1, k2 until kn, until the unknown parameter. Okay, and then the third one is your transfer function, how you want to calculate your transfer function, which is defined as your cs, which is your output, divide by your input, right? You will get your transfer function, and this is the general form of your transfer function. So from that, this is your your block diagram of your control system by representing of the output divide by input, and you will get your transfer function inside the box. So very simple. So that's the things that you need to remember, that you need to understand regarding to understand the transfer functions. And then the fourth one is the control transfer function system. So from here we have our general system. So for the first one, we go through the electrical network. So from here you have a 3 type of component that you need to remember and you need to understand, which is the capacitor, resistor, and the inductor. And then the relation between the voltage current voltage, and voltage charge will be stated here. You need to remember and you need to understand how to use this kind of formula. Okay, and they have your impedance here. So by inverse of the impedance of the formula here, I over V, you will get your admittance. Okay, your impedance is your total of your resistance. Okay, number of your resistance. Okay, so after that you have your translational mechanical system. So from that you have your spring, you have your viscous damper, and the last one will be you have your mass, right? From that you have the relation between the force velocity and the force displacement, right? From here, the point that you need to highlight here is your K, which is your spring constant, and then your Fv here, which is your damper, and M here, which is your mass, right? And then how you want to do, or how you want to use the term here is provided from the examples. You can go through on the example and you can see how they use all the terms here in order to get your system control, especially for your mechanical translational, right? So that is our previous lessons about the transfer functions in electrical and translational mechanical system. So we just want to add on another one type of the transfer system, which is the rotational of the mechanical system. Okay, this is the last subtopic for this topic. All right, so from that there's a difference between of the component here. For if you have a translational, you have your spring, you got the spring here, right? You get your viscous damper, and then previously you have your mass, but for the rotational you have your inertia, your moment of inertia. This is how you rotate of your system. So from here, the things that you want to highlight here is also similar with the previous one, which is K, we call a spring constant. You have D here. Previously you have your Fv, but now you have your D, which represent of the coefficient of the viscous friction, and you have a J here, which is your moment of your inertia, right? So now your relation is different, is dah berubah. Okay, last time you have your force versus your velocity, right, for your translational. Now for the rotational you have your torque versus angular velocity, and torque versus angular displacement, and this is how you calculate from your systems, right? You have your K, D, J, and respect with your delta T. Okay, your rotational terms. Okay, so I think for better understanding, we do the example 1 here. So the question is about find the transfer function theta 2 over Ts. Okay, the condition is the rod is supported by a bearing at either end, okay, and it's undergoing torsion. They have got the torsion here. The torque is applied at the left, and the displacement is measured to the right. So you have your torque on the left and the displacement measured on the right. So from here, the A diagram here is the physical system that provided to you, and so this is how you want to interpret the physical system into the schematic diagram. So from here you can divide the mass here, because we consider that this is 2 degree of freedom, so we have a two different mass here, J1 and J2. We separate it, and from that in the middle we have our spring, and at the end of the what we call of the free body of the mass, we have our damper for end of the mass of inertia. So from that, this is your schematic. So from that you have your free body diagram. So from here, this is your output and this is your input, and then you will get your transfer function system. Okay, so by solving this kind of example, you need to have two case. You need to consider by the two case. Okay, the first case is when you consider for the first system, and then the second case we consider for the second system, which is your J2 there. Okay, so from that, this is your your first one. Okay, this is your first one. You have your tt and theta 1t. So from here you have your tt here, your ts by convert into the Laplace transform. So you have your j1 here. Okay, j1. So you have your j1 s2 theta 1 ds theta 1s, and also you have your damper here, okay, which is your d1 s theta 1s, and you have your spring, right? This, you got your spring here. So they mention here k theta 1, and this is the rotational of your the rotation of your system. Okay, this is how your theta 1 direction move, right? Okay, so basically the value here s2 s here is from the diagram, the table that I shown you before this, and this is what that I tell to you, right? And then they just convert it into the theta t here to s directly, right? You know how to do that before this, right? So from there, so this is for your first system. So and then for your theta 2, by you considering of for the case 1, by considering the j1 is moved but j2 is fixed, so you will get your j2 k theta 2 here, which is fixed. We got the theta 1 direction from here. So by sum up, you will get the submissions of your systems, right? So you have your ts, which is your torsions, and this is your j1 s2 theta 1, which is representative of your mass here, and then this is your damper, and then this is your spring, and this is your k theta 2, which is fixed for this case. Okay, this is your first case. So from that, from the diagram of level C, you need to come out with the equation, which is important in order to solve this problem. So from that, you have your j1 s2 theta, okay, plus with d1 s theta 1s, and then plus k theta 1s. You just combine it, and you compile it with respect to the theta 1s, right? So because the direction is different with the k theta 2, which is fixed there, so we got the negative k theta 2s, which is equal to your torsions s. And this is your first equation of your case. And then for the second case, you will consider if the j1 is fixed and j2 will move. So same thing with the similar with the case 1. For the case 2, when j2 is moved, so you will create your j2 s2 theta 2s, d2 s theta 2s, and also your k theta 2s, and this is the direction of your theta directions, right? So from that, when the j2 is moved, the j1 will be fixed, so they have got the k theta 1 here with respect to the motions of the j2. So from the combination for both condition, you will get the submissions of the total submissions of the case. So from that, from the diagram of C, you need to come out with the equations of the system. So you have your negative k theta 1, which is here, which is fixed at this case. Negative k theta 1 because of the direction is against the directions of the system for the j2. So plus with j2 s2, you bring out the theta 2 here, you just compile it, d2 plus k is equal to theta 2s is equal to 0. So from that, you have your first equation, you get your second equation. So now you can directly to get the answer by doing the simultaneous equation, and then you will get your theta 2 over s over ts, which is your transfer function, is equal to k over the delta here. The delta here is submission of this one you time with this one minus this one times this one. You need to try this, and then you will get the answer for the transfer function of the system for theta 2s and ts. Okay, and this is examples. Another examples which is more complicated because they got a 3 degree of freedom of the system. Last time we have a 2, so we have J1, J2 and J3. Okay, you can try at home, and then you will get the results of the equation for the case for the system of the first degree of freedom, second degree of freedom and third degree of freedom, representing for G1, G2 and G3. Okay, you can try, and then hopefully you will get the same result that shown here. Okay, I think that's all for this topic. So before we stop, we have our tugasan 1, but this assignment, this tugasan 1 is just for student set number 1 only. Ya, untuk set nombor 1 sahaja perlu menjawab soalan ini. Okay, find the transfer function of this is for the mechanical translational system. This is like your tugasan 1 lah. And then please submit your solutions to UKM Folio, link provided by 20 of May 2020, which is next week on Wednesday. Okay, I will open the link for a submission, and again I remind again that this assignment is just for set 1 student. Okay, set 2 is already done. They just submitted before this. So set 1, please do this tugasan 1 and then submit to UKM Folio by 20 of May 2020. Right? I think that's all from me. Thank you to all for follow my class, my video class for this time. Hopefully we can see for the next topic, which is we talk about the system stability. And then one more thing that I want to remind is on 18th of May you guys have mid-sem. Okay, don't forget 18th of May around 4 p.m. until 11 p.m. you have to attend the mid-sem exam. I will upload it, the questions, and then you need to answer it and submit it before 11 p.m. for in the 18th of May. So the topic that cover for the mid-sem is this topic, which is the transfer function of the physical system, and also the another 2 topic from Dr. Salvinder. So you can prepare. You have another 4 days in order to prepare for your mid-sem. So good luck, and then I think that's all from me. Thank you and selamat berpuasa.